All right, so today we're going to be finding the slope of a line that passes through 2 points. In this situation, we're dealing with the points -4, 2 and 2, 6. So before we start, it might be helpful for us to first off, let's make sure we understand what this word means, the slope of a line. So sometimes I might refer to this word, instead of slope, I might say steepness if students are having a hard time visualizing what the slope means, right? So if I'm on the side of a hill over here, the steepness of a hill is directly how far down you travel for every step you take, right? The steepness of the hill up here might be significantly less than the steepness of the hill down here. So the same thing goes for lines. The slope, or the steepness, of the line is simply going to be the rate of change up as I go up compared to how far I go over. So you might see it written this way in your book as my slope, which we're going to use the value m. You'll typically find it in y slope-intercept form, y equals mx plus b. The value m is usually referring to the slope. And so you might see it written in your book as m equals the rate of change. Or how I like to refer to it is the ratio of the rise to the run. So what I mean by this is my rise, my ratio of my rise in green, I'm going to say, is how far up this line is going to go compared to my run, which is how far over this line is going to go. So one thing that we can notice here, if we just simply, let's give this point some arbitrary points here. Let's make this x sub 1 comma y sub 1. Now, if you're wondering why this says sub 1, it's because I am just making these two x and y values simply arbitrary. X1 is the first x coordinate, y1 is the first y coordinate, x2 is the second x coordinate of the second point, y2 is the second y coordinate, the y coordinate of the second point. So if I look at this graph, I might be able to just count, how far up does this go? Well, I might be able to just count by going over here and looking at the axis of the graph and counting it up. But that's not going to be very helpful if we get points that are incredibly far apart from each other, or if we get points that are strange looking numbers that we're not sure if we're confident in counting by hand. So we can deduce a little bit of a formula here. So if I consider how far up this graph goes, I know my y value is simply, if I have a xy coordinate, the coordinate that deals with how far up my point is my y coordinate right here, and my y coordinate right here. I know that if I change my x value, the y value doesn't change at all. The y value is the one that's going to give me a different height. The x value changes horizontally. So I know that instead of counting up, I can simply look at whatever this y value is, and I can subtract those two things. The distance between the vertical positions of the 2 points is simply going to be the difference between my two y values, right? So we can think of my rise now as just y2 minus y1, the difference between those two y values. And the run, how far over it goes, it follows the same idea. The horizontal change of this line, or these points, is going to be dependent upon whatever the x values are on these 2 points. And so if I want to find the distance between those 2 points, I need to take whatever the x value is over here, so x2, and I'm going to subtract whatever the x value is over here, which is going to give me how far over it goes from point to point. in terms of my x values. And so you also may notice that in your book, maybe it's highlighted or something, but instead of writing rise over run, your book might use a formula like this. Instead of saying rise, it will take your y2 minus y1. And instead of saying run, it might say your x2 minus your x1. That is just a fancy way of expressing that this is a mathematical way to calculate how far over or how far up these points are away from each other. Okay, so let's apply it to this exact situation. Let's go ahead and let's change some of these numbers in here. Okay, perfect. So in this example, our 2 points that we're dealing with are -4, 2, and 2, 6. So again, I could just sit here and I could count. This is 1, 2, 3, 4, all the way up here, and then 1, 2, 3, 4, 5, 6, all the way over to the next point. I could find that ratio by doing that. But again, we want to practice using algebraic formulas so that we can get better at solving for any circumstances, not just ones that are easy to count by hand. So if I write my points over here, -4, 2, and 2, 6, if this formula really works, m equals y2 minus y1 divided by x2 minus x1, the ratio of the rise to the run, then it reason should tell me that, I just counted this before, and it rises 4 as it runs. I counted over 6. As it goes up 4 for every 6 it goes over. So if my formula works, this should somehow get me a ratio of 4 to 6. So let's see if it works. So it doesn't really matter which one you designate as the first point or the second point, but I usually just go from left to right. So I would deem this as my x1, my y1, this would be my x2, and this would be my y2. So let's plug it into the formula. So m equals, and I have y2 here, so y2 minus y1, so it's going to be 6 minus my y1, which is right here. Here's where I got my y2. It's going to be 6 minus 2 over, ratio of that 2, my x values, which I will go ahead and write. My x2 is going to be over here. My x1 is going to be right here. So my x2 is 2. My x1 is, and it's minus my x1, which is -4. So my ratio, if I do a little algebra here, 6 minus 2 is 4 over 2 minus a -4, which that's really just the same as 2 plus 4. That is going to just be 6. So my ratio here, I found, is the same as the ratio as when I just counted up in the picture. So this formula is going to be really helpful because it allows me to calculate the slope of the line given the 2 points with relative ease. So you might have a 4/6 ratio of rise to run, or a slope of 4/6. You might need to take it a step further though. I know that 4/6 can be reduced to 2/3. So I would maybe take that extra step, reduce the slope down to, or the fraction down to the simplest form. And we know that the ratio of 2 to 3 is the same as the ratio of 4 to 6. So here is a good example of how we can find the slope of the line passing through 2 points by using our slope formula, which is right here, just as a reminder. M equals y2 minus y1 divided by x2 minus x1. I hope this helps. Have a nice day.